Welcome to MES Marampally e-learning.
Welcome to the lecture series on computer networks. I am Jasir MP, Assistant Professor, Department of Computer Applications, MES College, Marampally. In today's lecture, we are going to have an introduction to networks.
As we all know, the term telecommunication means communication at a distance, and the word data refers to information presented in whatever form is agreed upon by the parties creating and using the data. So data communications, basically we can call it as the exchange of data between two devices via some form of transmission medium such as a wired cable. So it is obvious that we need different components to fall in place to happen a data communication. So the topics discussed in this section are components of data communication system and data flow. As you can see in the figure, in order to happen a data communication in a proper manner, we need to have a center. You can understand it as a computer system, and you need to have a receiver. Both have a defined set of protocols agreed upon which the communication is going to happen, and there should be a well-defined message formatted message or packet, so that both the parties can send the messages according to the rules and regulations over a transmission medium. So basically, the 5 components of a communication system are the underlying rules and regulations or protocols, a sender and a receiver, and a formatted message, and a transmission medium. And the data flow can be simplex, half duplex, or full duplex. The figures are self-explanatory, as you can see. In simplex mode of data flow, the data transfers from one point to the other. The data transfer is always in one direction. You could think of it as a mainframe computer interacts with your monitor, and the data transfer always happens in one direction. The second mode of data flow is half duplex. Half duplex, you could understand it as two policemen talking over a wireless set. Whenever one person speaks, the data transfer in the other direction is not possible. So in half duplex data transmission, the data flow is possible, but at any particular point of time, the direction of data will be in one way. And in full duplex, without any restrictions, both the parties can transfer the data in either directions, as in telephone communications or video calls or such applications. And now coming to the topic networks. We know that a network is a set of devices, often referred to as nodes, connected by communication links. A node can be a computer, a printer, or any other device capable of sending or receiving data generated by other nodes on the network. And the link can be different transmission mediums such as cable or wireless mediums or optical fiber cable, whatever. The topics we discuss in this section are network criteria, physical structures, and categories of networks. The network criteria. We know that a network should have optimum performances. A network should be reliable, and the network should have sufficient security features so that the data is protected against corruption or loss. When it comes to performance, it depends on a lot of network elements. It depends on the computers, the processing speed, the processing capacity of the computers, the bandwidth of the transmission medium, the traffic in the network, and a lot of other criteria. It is measured in terms of delay. How much time does it take for one message to get into the destination, and the throughput. And reliability, we know that the network should be reliable. We cannot afford a huge rate of failure when we are transferring between nodes. The occasional loss of packets could be understood, but we cannot afford the frequent loss of data. So, reliability is measured in terms of availability and robustness. And we all are familiar with security. The data must be protected against any corruption or any sort of intervention from malicious users. So the data must be protected against errors and intruders. So that covers the aspect security. And when we come to the physical structure of the network, the types of connection could be point to point, whereas two nodes are there, a transmitter and receiver connected over a medium. Such type of connections are called point to point. And in multi-point connections, multiple recipients are connected to a network. And in physical topology, we are talking about the connection. How does the connection actually happens between the devices, and the types of transmission possible between them. The transmission could be a unicast one, where a message is intended exclusively for a destination. Could be a multicast one where a message is intended to a group, and it could also be a broadcast message where the entire participants of the network are intended recipients. As you could see, in point-to-point connection, only two systems are connected and an exclusive link is there between them. And in the multi-point connection, we know that multiple recipients are connected to the link, and the data could be simultaneously transferred to all of them. And the physical structure, we call it topology. The topology of a network could be mesh, star, bus, or ring. A fully connected mesh topology will have exclusive connections between each station, and the data transfer is directly happens between the two systems, whereas it doesn't have to go through other systems since exclusive data transmission links are present between them. And the star topology, you know that there is a hub and all the stations are connected to the hub, and the transfer happens through the hub. And you know that if at all the hub goes down, the entire network goes down. And in bus topology, we have a central bus, and all the systems are connected to the bus, and the data is transferred through the bus. Ring topology is similar to bus topology, whereas all the systems are in a ring, and there will be a token held by a particular station to make it enable to do the data transfer, and the token always circulates in the ring, and whichever station held the ring can transfer the data. Hybrid topology. You know that all these topologies that we discussed earlier could be integrated to form a hybrid topology. Just like in the figure where all the systems are connected to 3 bus and all the 3 buses are connected to a hub, which forms it a hybrid topology of a star backbone with 3 bus networks. And the networks could be local area networks, wide area networks, or metropolitan area networks, depending on the geographical area that covers the network. As you all know, local area networks, we are talking about short distances like a small room or a building. The local area network covers in short distances. It is designed to provide local interconnectivity. And also, one of the most defining features of local area network is that commonly it consists of homogeneous systems. Similar systems takes part in a local area network. Wide area network on the other side, it covers countries and continents. Internet is a classic example of a wide area network. It could consist of multiple local area networks, and it can have heterogeneous systems with different capacities, different operating systems, and different protocols. So wide area networks spans over a large geographic area. And metropolitan area networks, in all these aspects, comes in between local area network and wide area network. They could be intended to provide connectivity over an area such as a city or a campus. The figure just shows an isolated line connecting 12 computers to a hub in a closet. And wide area networks could be switched or point to point. The figures are self-explanatory. If two systems, as per figure A, if two systems communicates each other that are part of a switched WAN, the data must be routed through different switches. Whereas in point-to-point connections, there is an exclusive connection between your system and the internet service provider. So basically, a WAN, a heterogeneous network, is made of multiple WANs and LANs. Internet is classic example of one such heterogeneous network. As you all know, the internet has revolutionized many aspects of our daily lives. It has affected the way we do business as well as the way we spend our leisure time. Internet is a communication system that has brought a wealth of information to our fingertips and organized it for our use. Topics discussed in this section are organization of the internet and the internet service providers. Figure A depicts the hierarchical organization of the internet. You could see there are multiple internet service providers who receives the service from a regional ISP. The regional ISPs in turn receives the services from a national level internet service provider. And all the national level service providers are interconnected internationally. So this is the hierarchy of organization of the internet. In earlier times, only BSNL provided internet connectivity in India. Nowadays, private companies are also playing in this area, such as Reliance, Airtel, etc. We know that In order to make computer networks possible, we need protocols. And the entire lecture series is intended to explain these protocols that comes in different levels of TCP/IP. So what is a protocol? A protocol is synonymous with rule. It consists of a set of rules that govern the data communication. It determines what is communicated, how it is communicated, and when it is communicated. The key elements of a protocol are the syntax, semantics, and timing. Topics discussed in this section are syntax, semantics, and timing. Syntax. Syntax is the structure or format of the data, which means we should have a predefined structure so that the sender and receiver understands the representation of the data. It indicates how to read the bits and how the fields are delineated, how many bits are, for example, in IPv4, 32 bits are reserved for source address and 32 bits are reserved for destination address. So exactly the sender and receiver agreed upon the fact that the source and destination addresses will be denoted by 32 bits each. That is known as syntax. And semantics defines how to interpret the data, how to interpret these bits, how to decipher some meaning out of the bits. So semantics is about interpreting the meaning from the structure, the predefined structure or syntax. So semantics is the underlying meaning. And timing, finally timing. Timing tells you when the data should be sent and what speed at which data should be sent or at which it should be received. So there are different protocols to make this data transfer possible. So before the data transfer happens, the system might be able to check whether the medium is occupied or free. So what should it do if it see the medium free? Such things are dealt in timing.